Hi friends, and welcome to my new video on an exciting AI-related topic. Generative AI often feels overwhelming because we usually meet it through frameworks, platforms, and buzzwords. But underneath all that, the structure is surprisingly simple. In this video, I'll walk you through the core building blocks you'll find in almost every GenAI solution, regardless of the tools you use. So before we zoom into each building block, let's look at the full picture. This diagram shows the entire GenAI system at once. Nothing here is exotic. These same pieces appear again and again, no matter which framework or platform you use. Keep this image in mind as we go through the parts one by one. The most useful mindset is this: your Python code is fully deterministic. The language model is not. It behaves like a pure function with probabilistic behavior. Prompts act as the protocol that allows these two worlds to communicate. Once you see this clearly, GenAI stops feeling magical. At the center is the model itself. Whether it's accessed through an API or running locally, the model is stateless. Every call starts from zero. It doesn't remember previous requests unless you explicitly send that information again as context included in the prompt. Prompts are not just text. They are structured inputs. System instructions define boundaries and tone. User input carries intent. Examples teach the model what good output looks like. In practice, prompts are part of your interface design, not just strings. Because the model has no memory, we simulate memory by injecting context. This could be conversation history, application state, or anything else the model needs to know. Context is powerful, but it's also limited. It's important to keep in mind that more context is not always better, regardless the fact that the context capabilities of LLMs increase. When a system needs real-world knowledge, we retrieve it. This is commonly known as retrieval augmented generation, or simply RAG. In simple terms, we search our data, pick what matters, and pass it to the model so it can answer based on facts, not guesses. Tool calling is how language models interact with the outside world. The model doesn't execute code or touch systems directly, it proposes an action, Python performs it, and the result is passed back. An important development here is the Model Context Protocol, or MCP. MCP standardizes how tools, data sources, and capabilities are exposed to models. Instead of custom, one-off integrations, MCP provides a consistent contract between the model and the tools it can use. The important point is this: regardless of protocols or standards, the model suggests and your code decides and executes. Control flow is fully deterministic. It's just normal application code. While it reacts to probabilistic model outputs, the logic itself is predictable and repeatable. This layer is what keeps GenAI systems stable. Model responses naturally vary, and that's expected. The goal is not to eliminate variability, but to bound it. In practice, this is done in a few ways. You reduce randomness by tuning generation parameters like temperature. You enforce structure by requiring schemas or function-style outputs and validating them in code. You ground the model by injecting retrieved data, and you verify responses using rules or secondary checks. The key idea is that variability is allowed at the language level, but not at the system level. You don't control what the model says, you control what the system accepts. Models can sound confident and still be wrong. Evaluation and constraints protect your system. Outputs are validated, policies are enforced, and unsafe or low-quality responses are rejected. Without this layer, you don't have a system, just a generator. When everything comes together, a GenAI system is simply structured software. Deterministic code orchestrates a probabilistic component. The real engineering value lies in how you connect and constrain the pieces. Frameworks will come and go, APIs will change, but these building blocks stay the same. Once you understand the mindset behind GenAI programming, learning new tools becomes easy and building reliable systems becomes possible. Thank you for watching this lecture. I hope you found the subject as exciting and thought-provoking as I did. If you'd like more insights on AI, digital transformation, and other tech trends, be sure to subscribe to my YouTube channel. Take care, and I'll see you next time.